let's take a look at a couple of optimization settings to optimize our sim times for our whitewater. So to start with, I'm going to go to the whitewater object and under the creation tab, check off allow caching. Now, as we discussed before when saving out our base flip simulation, that's always a good idea to check this off before saving out your sim, because this is going to cut off on your simulation times and your RAM usage by a lot. And the second setting that I want to talk about, even though it's not going to be applicable for this shot, is under the advanced tab called use OpenCL. And you will see that it's grayed out, like we can't untick it or tick it. And that's because the enable density control is switched off. Now, obviously, if you end up using enable density control in your shot, this would be enabled. And as a result, under the advanced tab, the use OpenCL would be enabled as well. Now you can check it off or check it on. Now use OpenCL, when you check this on, it's going to use GPU, your graphics card, instead of your CPU or your RAM to compute the simulation. But this use OpenCL is only responsible for the density control. If the density control is switched off, the use OpenCL would be switched off as well. So don't confuse use OpenCL with all the other settings or whitewater sim in general. It only uses the density control part on the GPU if you have use OpenCL checked on, because density control can be time consuming when it comes to the simulation time. So it uses GPU to compute it faster. Now, there is a good chance if you're running a very high resolution sim, you would run out of your GPU memory, because GPU memory is not usually more than 8 or 11 gig at best, unless you're looking at very expensive GPUs. So I would suggest, if you're using density control, just check off use OpenCL if you're doing heavy sims, because it's going to crash on your GPU otherwise. Alright, so these are the two optimization settings that I wanted to go over with you guys. Now let's put our whitewater scale to its correct value. So what I'm going to do is I'm going to go to my ocean source, copy parameter my particle separation there, and on the whitewater solver paste relative references, and I'm going to multiply that value by 0.85, so it's going to be even higher res than our flip sim, giving us the value of 0.833 and then voxel size of 0.3332. Now let's take a look at the high-res flipbook of our whitewater points, and we have this flipbook here, and you can see there is a lot of points in the simulation. You're looking at roughly 45 to 50 million points. Obviously this is just a flipbook, so you won't be able to gather a lot of details as you would in a render, but because we have that gradient which goes from brown to white based on our velocity, it gives us a really decent idea of what we can expect from our render. But we have a lot going on. We have our repellents here, we have the overlapping of our whitewater here, we have the dripping behavior from our collisions on the cliff. So all in all, I think this is a very good looking whitewater sim. Now, if I go back to my SOP level, obviously we set up our DOP import field and our group delete node to delete all the unnecessary group that our DOPNet might create. What I'm going to do is I'm going to drop down a file cache SOP, and I'm going to name it whitewater sim. Load from disk, and obviously I went ahead and saved this sim out. So if I middle click, obviously you're not going to see anything on the first frame, but let's say 104, you can see you're looking at 48 million points, which is quite a good amount. And then I'm going to drop down a null here and say out whitewater sim. All right. And one other thing that I would like to talk about is a separate spray sim. And I have a flipbook of a separate spray sim as well, which is right here. And you would see instantly that it's a lot more chaotic, it's a lot more diffused, and it's a lot more lighter. So the density of these particles is very low, so they tend to float a lot more than our main whitewater sim. And obviously this is very helpful when you're comping and when you're rendering stuff out to have a spray pass separate and a foam pass separate, because then you would be able to mix and match easily in comp. So let's take a look on how we can set up our whitewater spray sim. But essentially, it's the exact replica of my sim here, except a couple of changes on the whitewater solver under the emission tab. Limits, forces, foam, all these settings are the exact same as our whitewater sim, but I made some adjustments in the emission tab, and obviously this is also set to 0.8 instead of 0.85, so I get a lot more emission out of it. So to start with, the emission amount I changed from 1 to 1.125, and that's not a big deal. Essentially you're saying, okay, take the same whitewater scale, take the same voxel size, and add just a little bit more points to my sim. The velocity multiplier, I put that to 2 because I wanted the spray to have a lot more velocity than my base whitewater sim, so as to give that feeling of lightly dense particles. And maximum initial speed, I put that to 20 as well because I want the initial speed to be a bit higher than my base whitewater sim, and the lifespan of 5. Right, aging rates. I switched the tables this time, so the bubbles and the foam aging rates are set to 50,000, probably an overkill, and the aging rate of spray is set to 1, which because I want to retain my spray element and kill my bubble and foam elements. And then I added some noise, so just add noise to my velocity and left everything else to default here. You can change a couple of things here. If you want more noise into your velocity, you can increase the amplitude here, but I left everything to default, and it gives us this really nice looking spray simulation. So that's our spray, and if I compare this side by side, so you can see that the whitewater sim, let's just play them side by side at the same time. So you can see that on the left, the whitewater, it's following our fluid a lot more, and it's sticking to the fluid, our main flip sim. And on the right hand side, we have our spray sim, which is a lot more diffused, a lot more chaotic, and a lot more floaty, if you may. So that extra element is there to add that, tiny bit of more detail to our shot here. Okay, so now let's take a look on how we can take our base flip simulation and apply some meshing to it.